Next, we're going to use the ratio test to assess the absolute convergence or divergence for the series, the sum from n equals 1 to infinity of n factorial divided by n times 3 to the n. So we begin by looking at the absolute value of a sub n plus 1 over a sub n, where a sub n equals n factorial divided by n times 3 to the n. So we have, substituting n plus 1n, we have n plus 1 factorial divided by n plus 1 times 3 to the n plus 1. And now we need to divide it by a sub n. Or we can think of this as multiplying by the reciprocal of a sub n. So we have an n times 3 to the n over n factorial. We can iterate a term in the n plus 1 factorial. And we can also drop our absolute values because all of our terms here are positive. So we have n plus 1 times n factorial times, in the numerator we have an n times 3 to the n. In the denominator we have n plus 1 times 3 to the n plus 1, we can write as a 3 times 3 to the n times n factorial. Notice the n plus 1's cancel with each other, the n factorials cancel with each other, and the 3 to the n's cancel with each other. So we are left with n divided by 3. Taking the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n, we have the limit as n goes to infinity of n over 3, which diverges to infinity. So we may conclude that the sum from n equals 1 to infinity of n factorial over n times 3 to the n will also diverge, because we said when the limit of that ratio is either greater than 1 or tends to infinity, the series diverges.